Hey, hi everyone. Welcome back to my YouTube channel. My name is Sunny Savita, and in this video, we're going to discuss about this re-ranking, guys. Yes, this re-ranking actually it's a very important topic of the RAG pipeline. Although in my previous video, I already discussed this re-ranking along with the hybrid search. I've shown you this re-ranking using the Cohere API. If you haven't checked that video, please go and check. You will get to know that how to implement the hybrid search. Hybrid search means what? Vector search plus keyword search. Okay, and there I've shown you this re-ranking also. But uh we have a different algorithm. Okay, we have a different models and all with respect to this re-ranking. So I thought, why should not I create one a dedicated video on top of this re-ranking itself? Not one, basically I'm thinking about two video, because we have so many topics, so many things. I'll be showing you the topic, that what are the topic actually we have with respect to this re-ranking, and then step by step, one by one, we'll try to implement it, so that it will help you for creating a robust RAG application. Yes. So let me show you the topic. So here, guys, you can see the list of the topic. The very first thing which we're going to discuss here inside this particular video, that what is a re-ranking. Then we'll discuss why re-ranking is important. Then we'll create our re-ranking. Okay, we'll implement the re-ranking in Python from scratch using this sentence transformer and this BM25 API. It's a TF-IDF algorithm itself. It's an updated version of the TF-IDF. Then we'll understand this re-ranking using the cross encoder. Okay, so cross encoder actually it's a model so which take the pair of the sentences. I will let you know how it works. So definitely using this cross encoder, I'll be showing you this re-ranking and all. Then we'll discuss about the Cohere API. We'll try to compare all these method from scratch, this cross encoder and then Cohere API. Then apart from this one, we have some other solution of the re-ranking, like this research paper, lost in middle research paper. Okay, which is a very important research paper and very useful as well if we are going to be implement the re-ranking. So I will show you the solution of this lost in middle research paper. Already we have a implementation using langchain and all. I will be showing you now. Rank fusion paper, this is also one of the important paper, rank fusion. So definitely we are going to implement this rank fusion also. Then finally flash rank, yes, this is also a very important one, and you will find out the solution of the flash rank inside the langchain also. Okay, so in this video I will be discussing till the Cohere API, and rest of the thing means 6, 7 and 8, right, we'll be discussing in the next video. I hope the agenda is clear to all of you now. Let's begin with the video. So first of all, guys, let me show you my YouTube channel. Here on my YouTube channel you can see recently I have uploaded a video related to the chatbot also. So I have implemented the chatbot using the Google Dialogflow. It's an end-to-end chatbot, and here I did the deployment also using the complete CI/CD pipeline. So before that, I have uploaded the video related to this hybrid search, and here in this particular video only, I've shown you this re-ranking approach using the Cohere API. Okay, if you want to know, if you want to like implement it, so definitely you can go and check out with this particular video, right? Great. So let's start with the video. So first of all, what I'm doing, so I'm going to be explain you the RAG architecture. I'm just giving you the quick overview of the RAG architecture. Now inside the RAG architecture, guys, what happens? See, uh, here is my data, which I divide into the multiple chunks. So here we have multiple chunks. Okay. Now why we divide the data into the multiple chunks, so that easily I can feed this data into the model, because we have a model is having certain limitations with respect to this context length. Okay, context length. Now after the chunking, what we perform, we perform the embedding. Embedding is nothing actually. Embedding is a numerical representation of the data, and then we store this particular embedding inside the database. So this stage, right? So this is my first stage, which is called the data ingestion. Now in the second stage, guys, what we do, we perform the retrieval, right? So let's say my user is asking any query. So I convert that query into the embedding, and then I perform the semantic search or similarity search. So as of now, we are working on this retrieval stage, right? We have already seen the data ingestion and all with respect to the different databases and all. Now, here in in this retrieval stage, I already talked about this. I already talked about this hybrid search. So let me write over here hybrid search. Now, my motto to discuss about this re-ranking. Okay, and then after the re-ranking, I'm going to be discuss the different retrieval technique also. We have various retrieval technique. So we have this sentence window search technique. We have the small to big document retrieval. Okay. Apart from this one, you will find out various different technique, right? So definitely I'm going to be implemented, not in this video. Okay. After 2 to 3 video, definitely I will be like coming up with this retrieval technique. I already created some material, and soon you will find out the video on my YouTube channel. So guys, if you haven't subscribed so far, please subscribe it. So now re-ranking. Okay. So first of all, guys, we need to understand about the re-ranking. What is this re-ranking? Let me write over here. So see, let's say we have a database. This is my database. Now inside this database, we have vectors. Okay. I like kept several vectors inside my database. Now let's say user is asking the query, right? User is asking the query. Now this query is going to the database, and here we are going to be perform the similarity search. Similarity search. Now once what I do, I perform the similarity search, right? So what we do, we retrieve the top k document. Okay. Top k document means what? So top match document, top similar document. So here, let's say we are going to be retrieve top k. It could be anything 3, 4, 5, uh, 10, 20, 25 and all, right? So let's say here we are going to be retrieve top 10 document. Okay, which is going to be similar to this particular query. So here is what, here I am having now top 10 document from where, from the database itself. Getting my point? So this particular document, now what I'm doing, so here, see, just look into the reg architecture. So this particular document we are passing, this is my rank result. Okay, rank result. I'm saying rank, not re-rank, right? So this rank result, this document which I retrieve, I'm passing to my LLM along with the question, and then this is going through the basically after generating the response and all, we are passing the output to the user. Okay, this is the complete RAG architecture, and this is also called the RAG pipeline, where we have three stages. First is ingestion, second is this retrieval, and the third one is what? Third one is the generation. I hope this is clear. Now, where this re-ranking come and what is the use of it? So here, let me explain you. So let's say if we are passing this particular data to the model. Okay. Now this data actually, this data, rank data, it could be a noisy, right? Means let's say based on this particular query, we are not able to filter out the sentences. There might be a chances. I think you are getting my point, what I'm saying, right? So I can give you a very good example. Maybe with that you can understand. Let's say there is a company. So here is one company which is coming to the college, right? So here is what? Here is my college, this one. So this company actually, it is coming to the college, and this company wants to hire some candidate, right? Now this company wants to hire some candidate, and here this college is having some sort of a list. Let's say there is 100 candidate who is going to be appear in the interview. Now this company actually is having a different filter criteria. So the first stage, right, what it is doing, tell me, is taking a aptitude test. Okay. Now in the second stage, what they are doing, they are doing a group discussion. So they are saying, okay, just do the group discussion and all, and we'll see your communication and all, how effective you are with your communication and what all thing, right? So the first stage is what? Aptitude. The second stage is what? Group discussion. And then whoever is going to be past these two stages, so those persons going to be appear for the main interview, right? For the main technical interview. So this is what? This is my first filter criteria. Here is my second filter criteria, this one. And then only whoever is going to be pass, okay, this particular criteria, so those student is going for the interview, right? This is the main motto. So the same thing actually we can do over here. So why should I perform only so why should I only take this top k document, okay, after the similarity search and all? So after collecting this top k document, okay, let's say I collected this 10 document, 10 more similar document. So why should not I perform the re-ranking over here, so that I can filter out, okay, I can filter out one more time my sentences, and I can provide the refined input to my model. I hope the thing is getting clear to all of you. If not, just rewind the video and rewatch it. it will be clear. Now guys, see, whenever we are talking about the re-ranking, okay, so what is the benefit of it? So if someone is going to ask you in an interview, so you can say, using this re-ranking, actually I can provide the relevant information. Here I can write, you can provide the relevant information to your model, because it's a two-stage retrieval. So two time, what we are doing, two time actually we are filtering the data. Okay, once I will show you in the practical, now the thing will be more clear to all of you. So two times what we are doing, we are filtering the data. It's a two-stage retrieval. Now the second thing is what? So here what we are doing, guys, by using this re-ranking, actually we are going to reduce the noise. We are going to reduce the noise from the data, and we are improving the efficiency of the data. Okay, so here the efficiency is going to be improved. I hope you are getting my point. Now if you are not getting, then definitely you can relate with this particular example, where here is my college and here is my company, this one, right? So in the first stage, actually what we are doing, we are going to be filter some candidate, we are filtering out the noise, right? In the second in the second criteria, actually we are filtering out the candidate again, and we are providing the relevant candidate only to my company. That's my whole sort of a motto. I hope this is clear to all of you. Now see, I hope this is pretty much clear. So what are method actually we have for this re-ranking? So first of all, we need to understand the method. I think all the method I've already shown you uh, over the like slide itself. But let me show you again. Okay. So guys, here for the method, actually, this is the table which I created for all of you. Now just look over here. So we have one cross encoder, which is a very famous method for this re-ranking and all. Now multi-vector is also there. Okay, LLM is also there, means we can use the LLM again for what? For sorting the, for sorting what? For sorting the output, the retrieval document. Okay, the rank document. Now here is what LLM API. So LLM API means what? Basically this GPT and Cloud and all. Then re-ranker API means dedicatedly the model which has been created for the re-ranking only, like Cohere, Mixword, genai and all. So here guys, if you will look into the type, so cross encoder, actually it's a, tell me guys, it's a open source, right? So already it is available over the Hugging Face, directly you can use it from there itself. Now performance wise, it is very good. Why it is good, I will let you know what it is doing in terms of practical. I will be showing you that. Now here the cost wise, it's a medium one. Now example, so here guys, this cross encoder, it's not a single model, right? This cross encoder, actually it's a repository. There you will find out the different model. Okay, inside the cross encoder itself. Cross encoder is, it's a mechanism. It's a name of the mechanism. Okay. Now inside that you will find out this BGE. You will find out this mixword and all. I'll show you the complete repository. Then the thing will be more clear to all of you. Now multi-vector retrieval. Multi-vector, basically this model also we can use for the re-ranking. So that is what, that's a cold word. Okay. Then LLM wise, rank Jeffer and rank T5. I think you know these are the open source model only. So performance wise, it is also good. Okay. And the cost wise, it is little high because it's a huge model. The Jeffer, actually it's a like a, it's a substitute of the Mistral itself. So it's a huge model. I think the parameter in the billion itself. And this T5 also, it's a very huge model. It's a Google model. Okay. So we can use this T5 as well for the re-ranking. Now LLM API, GPT we can use, Cloud we can use, but it's a private and the cost will be a very high of it. And here re-rank, Cohere API we can use, and it's also a private API. Definitely you will have to pay for it. But again, the cost is little high, means as a like you cannot use it personally, you will have to use it professionally only for your organization and all. Now guys, how this model is working for the re-ranking, see, whenever we are talking about the similarity search, now let's say here is my query, and here is what, here's my data. Okay, this one means my chunk. Now what I'm doing here, I'm performing the similarity search in between. Similarity search, right? Now based on the similarity search, let's say here is what, here is my re-ranked output, this one. So here let's say I have how many document? Here let's say I have 4 document, and the re-ranking again, I'm doing a second stage retrieval. So here I am having a 3 document now. See what is happening, you know. So this model, actually again, it is performing the similarity search and all. Okay, this particular model, we are going to be perform the embedding. Okay, so here is my query and here is my document. This particular document which I'm going to be retrieved. Okay, this one. So let's say in the first one, in the first stage, I have retrieved four document. So again, we are going to be perform the similarity search and all, and then we are going to be find out this particular output. So that's the use of this model. Now here is one more graph which you can see. So inside this graph, so just look into this particular graph. Here we are talking between this cost and performance. So what could be the cost and the performance? Okay. So if you will look into this zone, so this is the middle zone. So inside the middle zone, actually you will find out the medium cost and the performance is also medium. Now if the performance is going to be increased, in that case the cost is also going to be increased. Okay. Now I think it is a blur, but I can read for you. Cross encoder is a model basically which will give you the very good performance, but in the production it can give you the higher cost as well. Multi-vector, so this is also fine, but yes, cost will be high. Now keyword search actually, which is a technique which we are going to be implemented to this session from scratch. So it will give you the higher performance, oh sorry, the lower performance, and the cost also will be a lower of it. Here we are going to be use this BM25 API. It's an updated version of the TF-IDF only. Now most of the doubt and all everything is clear related to the re-ranking. Now usually you can understand this particular architecture. Let's start with a practical implementation. So practical implementation, so here is my practical, guys. So what is the practical name? The practical name is re-ranking from scratch. So for the practical, I collected a few documents. So these are my document. Document is nothing, it's a sentences only. So it is my list of document. Okay. Now for this one, for this particular practical, I required this sentence transformer. Now what is the sentence transformer, guys? It's a library which is having all the transformer based model like Word, BART, T5, GPT and all, right? You won't be able to find out the GPT. For the GPT, actually, we have a OpenAI, but yeah, it is also a transformer-based model. Now, whatever open source model and all, everything we have. So those a particular model you will find out inside this sentence transformer. For what? For the embedding and for the different tasks like text summarization or translation, summarize or this basically chatbot and all, for the conversational AI and for the even computer vision as well, right? So different model you will be able to find out. Now we have installed this transformer. Now after the transformer, guys, see here is what, here is my model. So I'm going to use this particular model. My model name is what? Paraphrase XLMR multilingual V1. Okay, you can easily check it over the Google itself. You will be getting this particular model inside the sentence transformer itself. Okay, now I'm loading my model over here. So here is what, here's my model, guys, inside this particular variable. Now after loading the model, see what is the length of the document, how many documents I have in total 8 document. Let me zoom in. I hope it is perfectly visible to all of you. Now here see, I'm passing this particular document to my model dot encode, and here what I'm getting my embedding, document embedding. So if you want to see the embedding, see here I'm iterating the for loop on top of the embedding, and here is what, here is my embedding. Okay, if you want to check the dimension of each document, so simply you can check the length. Okay, so first of all, let me show you the first embedding. Likewise, we have total 8 embedding. Getting my point? So document 1 embedding, document 2 and all likewise. So if you want to check the dimension of the embedding, see here, this is the dimension 768. Means this model, actually this model which we have imported, is going to be convert every sentence into 768 of the dimensions, right? I hope this is clear now. So I have created an embedding from where, from the document itself. Now I will have to create an embedding from the query also. So this is my query, and I'm passing this particular query to this model again. Okay, and see, this is the embedding. Now what will be the size of this query embedding? Tell me. It will be the same. It will be a 768 only. Now you can check out also. So I written the length of this query embedding, and what is my length? The length is 768. Now see, between this query and this embedding, right, this document embedding, I have to perform the similarity search. So this is the similarity search, guys. I'm getting a similar score. See, it's a very simple code. Okay, very simple and neat and clean code. So I'm getting what, I'm getting my similarity to the first document. Actually it is 16% similar. The second document, it is 45% similar. Third one 56, and here you can see this is the highest one, which is a fifth one, I think. So if I want to check the most similar document, so I can pass this particular data to this np argmax. it will provide me a index of the highest value. So here this is the index, and the index is what? Index is 5. I hope it is clear. Now see, if I want to get the corresponding document, so definitely I can get it. Here I am passing this particular index to my document, and see, this is my, this is what, this is my document, which is more this is most similar to my query. See, this is my query. What is my query, guys? Natural language processing technique enhance keyword extraction efficiency. Yes or no? Yes. So this is my most similar document. Efficient keyword extraction enhance search accuracy. Right now, if you want to like sort all the document, okay. So based on this particular score, can we do it? Yes, definitely we can do it. So here I have written a code for it. So what I'm doing, so here you can see I am going to be perform the sorting based on what? Based on my score. So this is my sorting, guys. Fifth, seventh, fourth, second, sixth, 1, 3, 0. So fifth index, okay, which I shown you just now, I shown you, right? So which is a that index, actually that document is a most similar document. Now after the fifth one, actually the seventh one, then fourth one, the second, then sixth. Now if you want to check all the document along with the score, okay, in a sorted format, so here is the code for it. So what I written, I took the sorted indices, and here I'm passing to the document. I'm getting the document based on my indices, and here is what, here I'm getting the similarity score also, right? So this is what, this is my rank document, guys. I rank this all the document. I hope now you got it. What is the meaning of the ranking? I can take the top K document. Let's say from here itself, I'm going to be collect. So this is my extra code for what? For the showing you the rank and all with respect to each and every document. Okay, this is the rank of each and every document. Now, from this particular document, let's say if I want to collect top 4 document, in that case, what will happen? Tell me. So here, see, I did it. I collected top 4 document, and this is what, this is my top 4 document from all this document. Okay, I'm just interested in this top 4. Now tell me here, this top 4 document is a read rank document or rank document? Please mention inside the comment section. So it's a, tell me, it's a rank document. It's not a re-rank document. Okay. Now see, here I got the rank. Now I have to perform the re-ranking on top of it. So what I told you that I have a query and I have this rank document. Now, one more time, I will do the filtering over here. Yes, guys. So for that, I'm using this particular algorithm. The algorithm name is what? Rank BM25. It is working on a keyword level. Okay, it is working on a token level. So guys, see, here I am going to be import this BM25 OK API from this particular module. Now, what I'm doing, so this is my top 4 document which I collected inside this particular list. Got it? So rank document, and I just perform the slicing, and this is my top 4 document. Now here I'm going to perform the tokenization of it, tokenization of each and every document. So simply I'm going to be call this document split. Okay. And here is what, here is my document. See, this is my first document, second document, third document. Why I'm doing it? Because this VM25, it always work on a token level. It is inspired from the TF-IDF, right? Now here is what, here is my split. Here is my like token of the query as well. So this is the token of the query. Now see what I'm doing. So here I'm creating an object, okay, where I'm passing my top 4 document, this particular document, this one. And after passing this particular document, see, here is what, here's my object, right? Now I'm calling this method get score, and this is my query. So corresponding to this query, I'm finding out the score with respect to each and every sentences. So what is my score, guys? This is my score. So first document, it is relevant 90%, 19%, second 16%, third is 17%, and the fourth document is 0%. Okay. Now see, here if I want to perform the if I want to perform the sorting, so I'm performing a sorting here with this particular logic. So this is my sort indices 2. So 0, 2, 1, 3 means this 0th one is a more similar. This one actually it is coming over here at the third place. This one it is coming over here at the second place, and this one is at the last because it is having a 0 similarity. Now see, this is my top 4 document. Agree or not? Tell me yes or no. I think yes. Now see, here is what, here's my query. Okay. Now re-rank document. So what I'm doing, I'm going to be find out the re-rank document. Okay, this is my re-rank document, guys. It's not a rank document. So it's my sorted indices 2. So I'm going to be collect the document from here based on this indices, and this is my score. Okay, based on the indices. Right? Now see. So this is my first sentence, okay, with this particular score. This is my second sentence with this particular score. This is my third one with this one, and here is my fourth. and this is re-rank document. Now see, if I want to pass the data, if I want to pass the data to my, to my model, so guys, I can, what I can do, I can filter out over here. Instead of passing this all the document, I can only pass this three document, because fourth one is not a relevant one now. It is giving me a zero. If I'm going through with this particular algorithm, I can simply pass the three document. Now see, I'm passing the relevant information to my LLM. I hope you are getting it now. What is the importance of the re-ranking? Now see here, this is my further code for showing the re-ranking and all, everything, along with the similarity score and all. That's it. Now, this is my rank document, means the first one. Okay, only rank. And here is my re-rank document, guys. Now you will find out the similarity. So efficient one, efficient keyword extraction, it is coming at the first place. Then understanding document, I think it is same. Okay. So understanding document, it is coming here third place, and there second place. Okay, which is the more similar. Now machine learning, it is coming in the third place, and this one is the wastage, means here also, here also, it's the same one. So this three document is an important one which I can pass to my, tell me, which I can pass to my model. Sorry, to my LLM model. Okay. Now here is the second thing. See, what I did, I performed the re-ranking using this BM25, and I shown you the chart. If you will look into the chart, guys, sorry, if you will look into the graph here, so BM25 is nothing. It's a where you will get the mediocre performance, because it is working on the keyword search and all. If you are passing a huge amount of data, or if you want to find out the more context from the data, in that case, it is not going to work definitely. So we want any other method, the efficient method, and here that particular method is cross encoder, right? This one. Now see here also I mentioned this cross encoder, this one. And cross encoder, basically it will give you the great performance, right? Now what is a cross encoder, guys? See, so once you will search over the Google now, cross encoder, so you'll find out this particular repository. Now this cross encoder is not a single model, so it's a many more model actually you will find out inside this particular repository, like dbirta, roberta, distilbot. Okay, most of the model actually is based on the bot only, because bot, it's a encoder. Okay, it's a encoder based model, so it's a different variant of the word, right? Now see how it is working, this cross encoder. So this is the architecture, guys, which is representing everything related to this cross encoder. I already kept it over here. So see, the input of the model, the input of the model always consists of a data pair. Okay, data pair. For example, two sentence and output a value between 0 and 1. So what we are doing, we are passing two sentences, means we are passing the data into the pairs, and here the output value we are getting between this 0 and 1, indicating the similarity between these two sentences. Two sentences means what? My query and my document. Okay. Now see, here I am passing my sentence A, sentence B. So this is what, this is my query, and here's what, here's my tell me document, and I'm passing it to my bot, and we are going to be classify the score, and the score is between 0 to 1 over here, right? So in backend, maybe it is going to find out some sort of a similarity and all. Okay, so we'll have to look into the backend functionality, but that's a working, the internal working of the cross encoder. Now if you want to check over the Google, so just search about the cross encoder. Now you will find out the different images. With that, actually you can easily understand the differences between the normal encoder and the cross encoder.